Welcome to PdMA Corporation, home of the MC EYE. I'd like to thank you for joining us as we continue along in our presentation series. Once again, we have the Vice President of Product Development, Mr. Noah Bethel.
Hello from sunny Tampa, Florida.
And I am Todd Gunderson, the Vice President of Sales and Marketing. And Noah, this is kind of unique to us because this is a new product we're announcing.
We are excited about it.
Kudos to the development team. This falls in line with what the industry has been pushing towards.
They have been pressing a lot, from a resource limitation to the need for higher reliability. It certainly is, come to a point where people need this type of permanently installed technology.
For their critical assets. If you have a highly critical asset that needs 24 hours of monitoring, the PdMA EYE is your solution.
Keep an eye on your motor 24 hours a day.
Right. And so this is what drove us into this marketplace. So without further, I would say, discussion of the PdMA EYE, let's just show you what it looks like.
And there it is.
And here it is. And maybe you can, first thing that strikes me is it's almost the same size as an MTAP.
It's a great point. In fact, the real estate, if you look at the size that it's going to take up, any of our customers who have installed test access panels, specifically the MTAP2, they're looking at basically the same footprint as far as the real estate.
So correct me if I'm wrong, it looks like it's 12 channel, even though the final spot there, input 4, is blanked off, but we're going to have 12 channels on this?
It is kind of a different approach for PdMA. Our technology has always been the 6-channel, 3 voltages, 3 currents for the portable EMAX technology. And what we decided with to expand the capability a little bit, we recognize there's a lot of variable frequency drives out there. You've heard us talk about the good, better, best plan. If you can get line side and load side, now you're doing, double the reliability studies and making sure that the drive is not affecting the distribution system. So all that being said, with PdMA EYE, you can do line side and load side analysis with the full 12 channels. Now, if if you're just looking at a standard across the line motor, now you got 6 additional channels. And one of the things we're doing is improving the precision. You've heard me talk about the inrush startup. It is my favorite test. We're improving the precision and resolution of that inrush test with using like the 3rd slot there, and that's kind of a big deal. And then of course we're making it available for the future edition of auxiliaries. If you wanted like RTD temperatures or an overall vibration, if you wanted to pump that into the
pressure temperatures.
Exactly.
Yeah.
Right.
Okay. So now this is powered through PoE, Power over Ethernet. Can you explain?
So that is by far the most popular installation. Through all the beta installations we've had, 100% of them use the Power over Ethernet. So we communicate in and out of this device with Ethernet connectivity, and rather than just relying for communication, we can also supply power to the unit through the same PoE connection. Of course, there is an alternate DC power supply that you can plug into Classic 120, and that's important to have as well.
So anything else you'd like to add to this? Like I said, the size is wonderful. It's going to fit in most of your control cabinets.
Yeah, I think that one of the big things we mentioned earlier is once it's installed, and again, the installation time is going to be again almost the same and probably less than an MTAP because we're not knocking a hole through the cabinet.
And if you have an MTAP in there, you can probably utilize the same CTs that were used in the MTAP if necessary.
Well, good point. Not so much the CTs, but the voltage connection. So you can definitely tap off the same voltage connections in MTAP, but you would need dedicated CTs for the PdMA EYE versus the MTAP2. Good
if
point.
you were going to put the MTAP, not necessary anymore.
Right. If you were going to replace the MTAP,
yeah.
Same CTs would go. But again, like I added, what we've done now is we've raised the resolution and precision of the inrush startup. So we now want inrush through that 3rd slot and power through the 2nd slot.
So what you're saying is now, instead of an MTAP where you have one set of CTs, you have 2 sets of CTs to catch that inrush, because inrush is significantly higher than normal running.
Absolutely.
Current. Okay. Now, this is the actual, how it communicates in your facility. You can see on the bottom row here, we've got a bunch of PdMA EYEs, and then it goes into a switch and then into a controller.
Yes, that controller is a key element. One of the things we didn't want to do was upset your IT department. by running, tons of motor test data through your network to the cloud. And as a result, we have certainly taken the popular approach of edge programming, edge processing, where we're doing a lot of the processing locally in that controller, as well as sharing some of the processing up into the cloud. By sharing that processing power or resource, it really minimizes the network traffic and keeps IT off our back.
Excellent. And then from the controller, it goes up to the cloud, correct?
Correct.
Through their network or through some cellular device?
That's a great point. There's a variety of ways that people are probably going to get it done, Ethernet being the standard initial communication. In the event that they don't want you to go through their network, certainly cellular options are there and available.
Especially remote locations.
Big
They're
time,
in the middle
yes.
of nowhere.
Which we've seen. In fact, one of our beta sites is in the middle of nowhere. And some people are transitioning the Ethernet into wireless or even into fiber optics. And so that's all available depending on your infrastructure demands.
So some features, 24-hour monitoring. Obviously, that's key, right? Can you expand on any of the 12-channel you talked about a little bit?
Yeah, it's the drives are a big deal. Auxiliary inputs are a big deal, and there's a variety of motors. So again, just like the EMAX, the portable technology, it's not limited to any type of motor. We are going to be seeing advances into, like, for instance, the DC motor. We're real pleased that with the PdMA EYE, we have no frequency limitations. So this is all the way down to DC, and that's kind of a big deal when it comes to online testing of the DC motors
or low frequency drives.
Exactly, or low frequency drives, which tend to cut off the
so what you're saying is you can actually put transducers in now instead of the regular CTs that go out with an MTAP.
A big step with the PdMA EYE is now we can get down to that 0 hertz, a very low frequency with actual transducers. And transducers can be the 4 to 20 milliamp, the 0 to 10 volt type. There's just a variety of transducers out there depending on what you're measuring.
And you talked about communication, data checking, safe. We've been tested, so we are safe.
Right. We talk about, the reliability interest is always there, but there's also a resource issue when it comes to the permanently installed technology, which has forced our hand in the market, right? If we don't have people to go out and do the testing, we still want to get that test data. Permanently installed solves that. And of course, much like the test access panel, we can't ignore the safety issue. When a unit is installed behind closed doors, monitoring 24 hours a day, your analyst can safely look at that data from the desktop, from his home computer, from wherever, even from the phone on the side of the beach in sunny Tampa, Florida, and be able to be out of harm's way or potential energized equipment. So that's a big deal.
And then communication, we talk about RESTful API. Can you explain a little bit of that to the viewers?
Absolutely. So API is general phrase referencing the integration, interoperability of technology or data, more importantly, to other third-party programs. MC Gold, great program. It focuses on motors and rotating electrical type information, but the information we provide is sometimes also companies would be interested in getting that data into a third-party program, an asset management program.
So you're talking data integration now.
Exactly.
Where you're taking our KPIs and delivering them into some other software package.
Right, and we automate it now so it can be done behind the scenes from a cloud-to-cloud type of relationship.
Excellent. So here we have as always, you know how we like to just say, don't listen to us. Of course, we're biased towards this technology. We think it should be in every facility in every part of the world or the globe. But we always like to back it up with a case study, right? And this is a great opportunity to share with you the PdMA EYE in action and how it detected a rotor bar problem at this remote facility that we talked about earlier.
Yes, a perfect example. They have they get to it every month or two in a pickup truck, and that's a resource issue, right? And as you know, this is in a pipeline situation, which today pipelines pumping gas kind of important. And we don't want those motors going down.
So this is the size. So it's a large size motor, obviously. Like you said, it's a pumping station, so it has to be able to put enough pressure on that line to get that fluid to the next station. Yeah,
this is a serious motor, and it's working very hard.
So the initial beta testing was placed, and they saw an issue with it once they put it on.
Right. What's interesting is to kind of bring some of the previous slides back, but this was a situation where we were not allowed on the network, period. They didn't want, and you can imagine a pumping station. This is critical network. This is operational. They don't want any kind of third party. If you're in that situation, a perfect example that we ended up going from the middle of nowhere onto a cellular router. And so we'll show a little bit about that. But for sure, right out of the chute when we installed this, just planning on monitoring a good, healthy motor and seeing if anything happened, we immediately started getting indications of a rotor anomaly.
Yeah, and so the nice thing about it is now you don't have to come back 6 months, or now you don't have to go back, because when we have a rotor bar anomaly, what do we tell people to do? Increase frequency of testing.
Exactly. Right. Minimize starts and stops, which good luck telling operations.
But if you're in the middle of nowhere and you get there once every quarter, and we tell you to increase, we're telling you to get there now once a week, that may not be possible.
It just does not happen.
It does not happen. Right. So the beauty of having something installed 24 hours a day, 7 days a week, collecting information, you can trend that from your office.
Absolutely. From another city, from another state.
From another
which is
state,
exactly what happened.
From another part of the country, as I was in the Philippines recently, and I was able to access our installed beta site.
Absolutely. And this was a situation where we were monitoring it obviously 24 hours a day, and we're having weekly conversations with the client that was doing the beta testing for us. So it became a pretty common conversation. They knew this was going on. They were able to look ahead and determine, hey, when is the right time to take action on this? And it worked out very well.
So this is how they installed it, and this is what we talked about. You can see here they're using 9 channels. And they're tapped off of, you can see that they're tapping, like you had mentioned, the voltage from the M-tap into the PdMA EYE, and then some additional current probes for each the startup and the running current of that motor.
Yeah, this is a perfect image of showing the real estate comparison between the PdMA EYE and the M-tap 2. And you're right, shared voltage and independent current inputs from CTs.
Right, and then you see the PoE, the Ethernet, how it goes along the cable tray there and right up into, that's where it's communicating, correct?
Communicating data as well as powering the eye.
Powering the eye itself. And we mentioned that this location is out in the middle of nowhere. So you had to use cellular to get the information up to the cloud.
Right. There was 2 parts. Even though there was a network tapped into this area, it was considered highly confidential critical network, and we were not going to be allowed onto it. It was their operations network. So this was an easy option for us. Just simply go cellular, find the nearest,
So the controller then sends the information through the cellular router up to, and it bypasses
the cloud.
Their network.
Exactly. Yeah. So IT was not concerned about it. On a funny side, we didn't have to fill out a 25-page questionnaire for cybersecurity, which we've gotten very good at.
we absolutely have.
Yes.
But it's always, this makes it easier.
It really
not?
did.
It
in
cuts
this situation, it was nice.
A lot of the concern, like you said, they don't want you on that critical, the network. If there's critical applications on that they don't want motor data on, we try to tell them it's just motor data, but doesn't matter.
Doesn't matter. It's their operation network, and we're not allowed.
So we've came up with this alternative as a end around to getting the data up to the cloud. So this was the test that shows the possible rotor degradation, and we've gone through a tremendous number of rotor bar anomalies, and we always tell you a couple things: minimize starts and stop.
Correct.
Right? Why? Because that's the most stressful time for that asset to go through 7 times the running current of a motor. But there's also other things. Know the design of your rotor, right? Is it a copper bar design? Is it spun cast aluminum? What's the speed of that motor? Yeah. That's very key.
It becomes critical for that centrifugal force. And as you mentioned, open versus closed bar design can be critical. If it's closed bar and the bar's not going to fly out into the stator, you have some more time. In this situation, I really think their decision was driven by opportunity.
Yes.
And opportunity cost to remove and repair or replace or to investigate to confirm what we're seeing.
More of a controlled evolution versus a middle of the night evolution.
Right. Gas pumping stops and everybody has got their hair on fire.
Everybody's got their hair. Yeah, right. If you know you're going into an outage and you know that you have a potential issue, the best thing to do is have a controlled evolution. Do you want to take your car? Would you rather have your wife call you on the side of the highway when there was a check engine light on that she had told you about
it's a nightmare.
6 months ago, and you decide, nah, it's okay, and then next thing you know, you get the phone call? Well, you know what happens then. I'll stop.
It's not good.
I told you to check that out. So this is a classic example of, okay, we're sharing with you the data, and we're having a controlled evolution. And this is the 5th harmonic, which and what this is really showing you, that it's seamless, right?
Yes.
This is PdMA EYE data, but it's seamless to the MC Gold software.
Exactly right. One of the beauties for our existing customers that have grown to use and love our software, understanding it as they do, the PdMA EYE is going to be such a nice, simple addition.
Yeah. So you don't have to learn a new software program.
Do not. Right. We're adding a couple neat things, but as far as the basics, it's going to fall right into the standard operating procedure for MC Gold. And this fifth harmonic is, as you know, for 4 poles and greater, a key evolution in the determination or verification of a rotor anomaly.
We always say correlate.
Absolutely.
Make sure you have multiple data points pointing in the same direction. And this is the third look at it through our time domain, which is the MC Gold software again, but it's PdMA EYE collected data.
Right. We set a band alarmer on the pole pass frequency. It went into the caution up towards the severe level, and it's a great catch.
So they sent the motor off to the shop, and this is the shop's response to them, letting them know that yes, there was a quantity of 5 bars, and he attached the pictures, which we're going to bring up here.
Pictures worth 1,000, right?
Right, 1,000 words. So kudos to the PdMA EYE, kudos to the team,
yes,
for pulling it at an opportune time when pumping may not have been, or the requirements weren't as necessary.
Right.
So,
and even with the pressure was a little lower, obviously because of timing and scheduling, and he was able to get that done. But he still was. There's always a wonder. We hope we're not making the wrong call. Everything turned out, as you can see, just right.
Right, and naturally, these rotors always have these arrows on there when bad things happen.
Yeah, an arrow indication. if your motor comes back with an arrow, it's never good, right?
It's bad.
Yes, it is bad.
If you have markers on your rotor, it's bad.
The yellow writing is never a good thing. One thing I like to point out here, you mentioned earlier, open bar versus closed bar design. These are open bar designs with a higher risk of secondary damage to the stator, but we caught it early enough, flagged it, tracked it, trended it, and made a decision at the right time. You can see the cracks are obvious, but the slots where the rotors going through the iron are not burning up. So we caught this early enough that this rotor can be repaired and basically put back in service.
You see some heating on one of those bars there on the top of the by the lamination up there, maybe traveling along the side. But another thing I noticed in this middle picture, it says 76. Well, that's how many bars are there. And how many times do we always tell our customers, develop a relationship with the motor shop, when you send motors in for bearing or whatever, have them pull that rotor if you don't know the number of rotor bars, and then just count the number of rotor bars on there. It really helps you out with eccentricity, correct?
Absolutely. As far as having that added to the birth certificate, it's huge for the analyst.
And then they got the replacement motor, and everything is down below the observe line. So we're back to normal again, it looks like. Now, you talked a little bit earlier, you said there's going to be some new software attached to this PdMA EYE version of MCE Gold, and this is one of them. It's called our Historian.
Right. Yeah. So we're real excited about the Historian. In fact, as an analyst, I'm convinced that there's going to be as much. This is going to be as much the first go-to, screen that people use when they're entering the analysis stage. So, at this point, you can very easily see that the starts and stops on this motor are pretty frequent. That doesn't help the rotor bar situation. It doesn't mean it's going to stop. It just means that they need to be aware of that and elevate the concern about rotors. But yeah, we're extremely excited from an analyst perspective that the Historian is going to provide a much broader depth of first steps in analysis.
What I see is you can blow it up with full, I want to look at all the data, or times 2, times 4, times 8. We also have a drop down there where the percent FLA, so there's more than just percent FLA that we're going to Historian. There's a number of things that we're going to put in the Historian.
I would say 20 to 25 different KPIs that we're going to be populating the Historian with.
And then on the bottom I see 1 day, 5 day, 1 month, 3 month, 6 month. So that allows us to really focus in on a specific area?
It really does. In fact, what you'll allow you to do is do a quick broad sweep. Okay, if you see activity that occurred 5 days ago or last month, you can quickly identify that, then dive into it, and that can become a real important issue as far as when operations says, "Hey, we had something happen." If it wasn't enough to set off an alarm, and again, this is going to be married to your mobile app, so it's going to send you an alert, tell you something's going on, allow you to go back and take a quick look as to what's going on.
So, Noah, I want to thank you for this opportunity to talk about our new product. Once again, congratulations to you and your team. There was a lot of thought that went into this. We think it's going to meet the needs of many individuals for highly critical assets out there. And as always, we hope the audience gained something out of this to make their tomorrow a little bit easier, a little bit better, because now more than ever, it's the best time to be in the reliability field with supply chain issues and everything else, that you control so much of what happens in that maintenance with your ability to detect issues before they become catastrophic.
It is the right time.
Right time, right place. As always, once again, thank you. We hope you got something out of this today that makes your tomorrow a little bit easier.